Hey guys, so today you are going to be working on reviewing solving quadratic equations. And then we are going to actually look at a third way to solve quadratic equations. But to review, there are two methods you've already learned in how to solve a quadratic equation. One of them is factoring, and the other one is using the quadratic formula. So you are going to end up reviewing both of those items here real quickly, and then you're going to practice that then here after the video. So hopefully you remember in factoring, the whole goal was to make it look like two quantities being multiplied together where your x's in the front have powers of 1. Okay, so this is our ultimate goal, to rewrite a polynomial as a product of two linear factors. So the way that we learned how to factor was to figure out two different numbers, two factors that will multiply to get negative 32, but will then add to get the positive 4. And so you really, you had ways to do this in your calculator. You could really just look and, divide the negative 32 by a bunch of numbers and see which pair works. Just to show you real quickly what that would look like. You would, whoa, what's it doing here? There we go. You would be taking that negative 32 and you would then, whoops, sorry about that. Oh my goodness, it's going crazy here. Okay, so you take the negative 32 and you would divide it by 2. And that gives you 2 and negative 16, but that doesn't work for the positive 4, so you'd continue on trying to figure out which number does work. So negative 32 divided by 3, we try that again. That doesn't even give you a possibility because that negative 10.6 repeating is not a whole number. We try negative 32 divided by 4. We get 4 and negative 8. So if we think about that pairing of numbers, a 4 and a negative 8, they do multiply to get you to 32. So that's the first part. But then the adding part, if I try to add those together, it gets me a negative 4, which means this is not our number. And so then what this would really mean, since we got the negative version, that just means our negative's on the wrong number. So we would then reconsider and we'd make the 4 negative instead. So the 4 will be negative and the 8 will be positive, which still multiplies to get you the negative 32. But then whenever you take negative 4 plus 8, that'll end up giving you the 4. So these two numbers are the numbers that go in your parentheses then with your x's there. So it'll be the quantity of x minus 4 times the quantity of x plus 8. Okay, now we have to remind ourselves that this is an equation. So we're able to now to solve for x, knowing that we have this quantity and this quantity here being multiplied to get me 0. So we use the zero product property to show or to see which numbers would work for the x. So we're going to take this linear factor and we set it equal to 0 and we solve for the x. And what this does is it tells us a number that we could plug in for the x value here that's going to make 0. And then if this whole quantity is 0, then it'll multiply onto here and make 0 in the end. So this number here, if you put a 4 in there, that makes 0. And then 0 times anything is 0. So it satisfies the equation. The other factor, the x plus 8, the other parenthesis here, also gets set equal to 0. There's going to be two possibilities for this problem. When you solve this by subtracting over 8, you end up getting x equals negative 8. That number, if we plug it back in here, it's going to give me negative 12. But then if you plug it in here, it gives you 0, and negative 12 times 0 is 0. So these are the two numbers that actually work for that problem, and that's why we factor. So we factor using the multiply and add, and then once we get those two linear factors, we set them equal to 0 using the zero product property, and we solve for x to see those numbers. Okay, let's take a look at the next example. So we're multiplying to get negative 10, and we're adding to get the negative 3. So hopefully you thought of the numbers negative 5 and 2. So negative 5 times 2 gives you the negative 10. And negative 5 plus 2 gives you the negative 3. And so the negative 5 and the 2 are the numbers that go in your parentheses. Doesn't matter what order you put them in, okay? So you can put the plus 2 in the front and the negative 5 in the back, or you can put it how I have it here. Now we take each of those linear factors and we set them equal to 0. So x minus 5 equals 0. We add over the 5 to get x equals 5. And then here, x plus 2 equals 0. Subtract over the 2, we get x equals negative 2. So again, this is all review. I'm going through it quickly, but you guys should have already mastered the factoring. I'm just reminding you about this part. So this part here is what we're trying to look for, all the x's that make the equation true to be 0. Now in this factoring, remember that we also have a technique called the slide and divide. The slide and divide happens whenever you have a number out in front of your quadratic term. And we slide that back to the negative 12 and we multiply those two, which gets me a negative 24. And now my puzzle is I tried to add to get that negative 24. Multiply to get the negative 24 and add to get the 5. So those two numbers that work for that are an 8 and a negative 3. So remember that we just be dividing the negative 24 by a bunch of numbers until we got the pair, and here's the pair. And so now what you do is you will have those as your linear factors, but you have to now undo the original multiplication that you did. So that green part here is the slide. Then we're going to go ahead and do our divide step, which means that same number we slid over, we're now going to divide back off to undo that multiplication. And in this step, we have to reduce our fraction. If you need to use your calculator, you'll just type 8 divided by 2, and that does give us a 4, so x plus 4. And then you'll take negative 3 divided by 2. But in your calculator, it's just going to give you a decimal. Remember that we can convert that back into a fraction by using math enter. It actually spits back out the exact same fraction because negative 3 halves can't reduce. There's no common factor between 3 and 2. So if you knew that, you didn't have to put in your calculator at all. The last part that we have is what we called the bottoms up. So any bottoms or any denominators that you have are going to swing now up in front of the x term in that linear factor. So my final factored answer looks like x plus 4, and then this 2 comes up in front of the x, and then I just have the minus 3 left over once I move that 2. And here is what my factored version of that example 3 quadratic polynomial is. Now, what I'm doing is finding the solutions or finding the zeros. I'm going to solve because this is technically an equation still. So I'll take each of these linear factors, set them equal to 0, and solve. So I'd subtract the 4, getting me a negative 4 for this one. And then I solve the 2x minus 3 factor. And I would add over the 3 first, and then I would divide off the 2, which gets me 3 halves, which would be the 1.5 as a decimal. But these are my two solutions. Last slide and divide problem. We've got a linear coefficient. I'm sorry, it's not the last one. We got one down here. Slide down here. That gets me negative 60 when I multiply those numbers together. Okay, so now my puzzle is to multiply to get negative 60, but add up to get me a negative 11. And those two numbers that work for that, hopefully you're able to figure out, are negative 15 and 4. Negative 15 times 4 gives me negative 60, and negative 15 plus 4 gives me the negative 11. So it works for both of the parts of my puzzle. So I have an x minus 15, and then I have an x plus a 4. After that, we do our divide step. So we slid. Now we're going to go and do our divide step. So we divide by the 12 on both of these numbers here. Now we also remember we have to reduce, so you can put those in your calculator if you need to. 15 and 12 have a common factor of 3. So if I divide a 3 out of the 15, I'll get 5, and divide a 3 out of the 12, I get 4. 4 and 12 have a common factor of 4. So if I take and divide the 4 by a 4, I get a 1, and 12 divided by 4 gives me 3. The last step is to bring any of these bottoms back up in front of the x. So the slide is the green, the divide part is the purple, and now the bottoms up part is the black. So now the 4 will come out in front of the x, which makes that linear factor 4x minus 5. And then the other one will show up as a 3x plus 1. And remember, this is an equation, so it is set equal to 0. We're going to, whoa, what are we doing here? Okay, so now we're going to go ahead and solve each of those linear factors by setting them equal to 0 and figuring out what x equals. So we'd add over a 5 for this one, divide off the 4 and get 5/4. And then over here, 3x plus 1 equals 0. Subtract over the 1, we get a -1. Divide off the 3, we get -1/3. So those are my two solutions. Now they're uglier solutions, but that's okay. All right, last problem. So our slide, I know I have to slide because I have a leading coefficient. There's a number in front of the x squared. So slide the 6 back here to the 1 by multiplying, and that gives me 6. And then I have to multiply to get 6 and add to get the 2. But when you look at all the options to multiply to get 6, your options are, and I'm going to write them in pink, your options are 1 times 6, 2 times 3, or you can do -1 times -6 and -2 times -3. Those are the only ways that you can multiply numbers to get the number 6. So this means that this is going to be not factorable, because even though we have these 4 options to make a 6 when we multiply, when I try to add them up, so if I do 1 plus 6, it gets me 7, and I need to get 2, so that's not right. If I add 2 and 3, that gets me 5. I need to get 2. That's not right. -1 plus -6 is -7, so that's not right. And then -2 plus -3 is -5. So none of them gave me this second part here. And so that means it's not factorable. Now, it does not mean that it doesn't have any solutions. It just means our solutions are not rational. They're not numbers that can be written as fractions. So that's why we have the quadratic formula, and we're going to revisit that in the next video.